Okay, final one of the four topics in the module on data interpretation, and now we're on to planetary systems, so it's like climate change, etc. And of course, we start with our very own Johan Rockström. Why do I say our very own? Well, he's an alumnus of SLU, and he's probably the most famous of those who pioneered work on planetary boundaries, which, according to their originators, define a safe operating space for humanity. And you can have a look at the original paper through this link. Here's the sort of publicity blurb for the latest version of the sort of planetary boundaries paper, if you like. The update on planetary boundaries clearly depicts a patient that is unwell as pressure on the planet increases and vital boundaries are being breached. We don't know how long we can keep transgressing these key boundaries before combined pressures lead to irreversible change and harm. The new study is the first to provide a complete checkup of all 9 processes and systems that maintain the stability and resilience of our planet. While transgressing a boundary is not equivalent to drastic changes happening overnight, together they mark a critical threshold for increasing risks to people and the ecosystems we are part of. Okay. So, how do we think about this? Well, here's one way that might help. Imagine you're a scientist and want to test, perhaps stress test, see if you can disprove the idea that a particular level of nitrogen flow to water marks a critical threshold for increasing risks to people and the ecosystems we are part of. How might you go about that? Okay. Here's another question to do with planetary boundaries and sort of the questions about ecosystem collapse and so on more generally. How many people would find their current homes underwater in the worst case for future sea level rise? Okay, so we're just trying to get our heads around how bad is the worst case, and to have something to compare to how many people are currently so poor that they have scarcely enough to eat in the world today. Okay, so just trying to think about putting this planetary boundaries stuff into a bit of a context and comparing it to other things. Okay, 3 authors this time. Okay, the second one we're going to look at is Toll, and again you can think about the this picture, where's Rockström, or if you're a sort of, yeah, where is Rockström, where is Toll, and where is Pindyck? Okay, Pindyck is the third one we're going to look at. Okay, there was Rockström, now Toll. Richard Toll, he's a well-known and highly published environmental and energy economist. He's perhaps the most well-known of those economists who argue, like the serious research economists, not the sort of climate deniers. Okay, he's not a climate denier. But the most well-known of those sort of serious economists who argue that climate change is more of a bump in the road than like an existential threat. Okay. So here's the abstract from one of his relatively recent articles. Current estimates indicate that climate change will likely have a limited impact on the economy and human welfare in the 21st century. In fact, the initial impacts of climate change may well be positive overall. Okay. However, in the long run, the negative impacts dominate the positive ones. Negative impacts will be substantially greater in poorer, hotter, and lower lying countries. Okay, poverty reduction complements greenhouse gas emissions reduction as a means to reduce climate change impacts. Although climate change may affect the growth rate of the global economy and may trap more people in poverty, quantification of these impacts remains difficult. The optimal carbon tax in the near term is somewhere between a few tens and a few hundreds of dollars per ton of carbon. Okay, so a lot of content there, a lot to think about. Okay, a lot of quite separate statements. Okay, this is a good abstract basically. I want you to think about ideally all of those statements. What sort of methods do economists actually use to measure climate impacts? You can get an idea of that by looking at the appendix of the Toll's article. Have a quick look at this Barecha et al. 2016. Are we passive victims of increasing temperatures, or do we adapt? Well, of course we adapt. Where is it easiest to adapt? How can people in sub-Saharan Africa adapt? To get an idea about that, well, I'm sure hopefully many of you have an idea straight away how they adapt, or many of them. But have a look at this paper. How far from the mainstream is Toll's estimate of the optimal carbon tax? Okay, so a bunch of questions here on Toll. Finally, Pindyck, another prominent economist, perhaps the most prominent of those who argue that the mainstream approach, which Toll adheres to, building so-called integrated assessment models to investigate the social cost of carbon and hence recommend the level at which a tax on carbon emissions should be set, is deeply flawed. So Pindyck says the mainstream approach is deeply flawed. And here's bits from his, again, not so recent article, 2017. IAMs are useless. They create a perception of knowledge and precision that is illusory and can fool policymakers into thinking that the forecasts have some kind of scientific legitimacy. How do we know that the possibility of a catastrophic outcome is what really matters? Because unless, well, basically, and this is sort of what Toll says, in a way they agree, that if we don't account for catastrophic outcomes, then it's clear that climate change is just a bump in the road globally. Okay, it's definitely not just a bump in the road for some people in some parts of the world, like sub-Saharan Africa, low-lying small island states. That's not a bump in the road. But in terms of the global economy, if you're thinking like Extinction Rebellion, we're all going to die. If we rule out the sort of unlikely catastrophic scenarios, we don't account for those, it's like, no, we're not all going to die. But what about those catastrophic scenarios? Can we just say, oh, they're so unlikely that we don't need to worry? Pindyck says we can't say that, we should worry about them, and therefore that they are the main worry since the scenarios that are predicted as most likely just aren't that bad. So therefore the main worry is the catastrophic scenarios, even if they're unlikely. If catastrophic outcomes are key, does that mean we can't measure expected damages and hence an optimal tax? Or what do we do instead? And if catastrophic outcomes are the key problem or question, how does climate change rank in the pantheon of global threats? In other words, what about other threats? See, for instance, Boström, the vulnerable world hypothesis. And of course, any question like this, you need to be careful about falling into something called whataboutery. Okay, I don't know how many of you know what whataboutery is, but if someone says we should do something about climate change, it's not a great argument to say, but there's this other more important thing we need to do something about. That's not really a counter argument, is it? It's like that would say, yeah, maybe we should do something about climate change, but we should do something about this other thing as well. Okay. But still, it's interesting. Nevertheless, we're aware that we need to watch out for whataboutery, but it's still interesting. If the problem is catastrophic damages, truly catastrophic outcomes, then presumably other threats that could, with a small probability, give rise to catastrophic outcomes should also be, we should be paying a lot of attention to them as well. Okay? And people like Nick Boström are doing that. So have a look at one of his papers. Okay, and that is just my introductory blurb on the fourth topic.